PSI at 28 days. How do you know that? So the way you do it is, Derek tells you here's the concrete, you get someone to make cylinders for you, and you do a standard cure, and then we test them. This is called standard curing. It's a big deal to understand the difference here, because you're putting them in water, and then we are going to test it and confirm it gets to 4,000, at which point you need to pay Derek his money for the concrete, right? Because it achieved the strength he told you it's supposed to achieve. That is called standard cure. Does this have any relationship with what we have in the field? Remember, in the field, you put the concrete maybe on the road, you're not gonna cover it in water. It's not gonna be exposed to standard temperature. So do you guys see the difference between what we're doing here? Standard curing is to measure what the producer promised you. We have another way of doing these things. So if you're putting it outside on a garage, you leave those concrete cylinders out in the garage and you bring them back here anytime you want to test them. Those are considered field cured samples. Those are more representative of the structure. This is not representative of the structure, right? This only verifies what you are promised. It does not verify what is on the structure. But a lot of times people will tell you, oh, this got to 4,000, out in the field it's 4,000. That is not correct. So you want to understand the difference between standard curing and field curing. In the lab, we do standard curing, and that is to verify what the producer promised you. And that is what we're going to do. So we'll strip, and this is how you strip the cylinders. So pull it out. This guy has a notch, and you have to do it either on the wood or on a mat. Please don't do it on the actual floor, because you're just going to damage the floor. And you put this guy on an edge, so small notch. Put your foot somewhere there. Strip all the way down. Take it out. Oh, I forgot to get my permanent marker here. And because I was group S, I will put right at the top S1. I will take my cylinder, put it in the water, in lime water. If you're group 1, so it will be G1. If you're group 2, it will be G2, all that and all that. Once you're done, you take 2 cylinders, we will bring them here, and we will do the actual testing for the cylinder. So we use underbonded cap system. It is important we have this flat. We'll put it on there. This is called an unbonded capping system. Top, bottom, and then we'll load it on our machine. Machine on. Load our machine until the guy crashes. And then we're done with the test. Take it out, throw it out, throw the debris out, record the load, and we're done with the loading test. That is what we're going to do today. Are there any questions?
No.
Go ahead. Sorry? Oh, so we're going to break 2 for each group, and then the others go in the water for standard curing. Yeah. So, how do you operate this machine? I will operate the machine for you guys so that we can go fast. But if you want to understand how we do this is what you want to look at. So, these machines come in different kinds of varieties. There are machines where you put your sample in, press a button, and it will crush everything for you. We're not that rich. So we have a machine that goes manually. We have full advance, metered advance, hold, and retreat. Retreat brings the platen down. Full advance brings the platen up. So you want to test your samples under metered advance. Like we said before, there's a way for doing everything we do here. If you break the concrete too fast, you have very high strengths. What's the problem with that? If the concrete was weak, suddenly you're reporting to your engineers this concrete is very strong. But because you tested it wrong, you are giving erroneous results. If you break it very slow, yeah, it will give you an accurate result, but you're also just wasting time. So there's a standard way to break them, and there's a standard speed you use. In this case, when we're testing the concrete, we're supposed to go at a specific speed, which is 35 plus or minus 7 PSI. You guys understand how we calculate the PSI, right? So we're gonna load it, and the machine is gonna tell us the load in pounds. The load in pounds divided by the surface area, which is this area here, gives us the PSI, the strength. That's what we are interested in. Any questions? No. All right, so most concrete is evaluated for strength at 28 days, but it also depends on how it was designed. If it was designed for a road, do you want to evaluate the strength at 28 days? You want to do it almost immediately. So some concrete for the roads is designed to achieve maximum strength within hours, 4 hours or whatever. You can do almost anything with concrete. You can design concrete that will achieve strength in 2 hours, depending on how you do these mixes and those kind of things, what kind of additions you add on there. So, having said that, I will crush the first sample and you guys can see how it works. And then, whichever group is ready with their 2 samples, we will proceed and start crushing them. It's a good idea for just the group that is watching to come close, see what is going on. The other people can wait around or strip their cylinders and all that. So we don't all have to crowd around one machine. We'll try to go very fast because this is supposed to end in about 30 minutes. So we're not going to break them at the right speed because we will not be able to finish on time. We'll try to accelerate it. But the bottom line and the point to understand here is there's a proper way to do it and there's an improper way to do it. If you do it the wrong way, you get bad results. And you don't want to report the wrong results. So, you guys ready to start?
You send our videos.
All right, so we'll break one